In this video, we're tackling the somewhat notorious integral secant cubed x dx, and we're asked to use integration by parts for this. Without being given that clue, you might mess around with trig identities for a long time before you realize that it's just a dead end and you need something else. So it turns out integration by parts is the way to move forward with this. And if I'm thinking integration by parts, then I'd like to find a piece for which the antiderivative is easy to guess. So secant squared is easy to guess. That comes from tangent. So I split off a secant squared from the secant cubed, and now I'm going to make my integration by parts substitutions. Remember, dv is chosen so that the antiderivative is easy to guess. So dv is going to be secant squared x dx. U is the leftover other piece, that's the secant of x. So I need to get du, and that's secant x times tangent x dx. And then v is the integral of this secant squared. That's just the tangent function. So I continue with my integral. I apply integration by parts, and I get u times v, that's secant times tangent, minus the integral of v du. And I can clean up that integral a little bit. And if you stare at that integral for a while and try a couple things, you'll realize it's not as easy as it looks. You can try breaking things down into sines and cosines. You could try looking for ways to do a u substitution. For example, if I thought of this as u squared, then u would be the tangent function, and the derivative of that is secant squared, and it doesn't work because I only have one copy of secant. And so again, we just hit dead ends with everything we try. So this is where the looping trick comes in. I'm going to look at tangent squared as secant squared x minus 1. And this is a good thing because when I distribute this secant, I'm going to end up with the integral of secant cubed over here. I'm going to go ahead and split the integral into two pieces. So one of them is secant cubed. The other one, I have a negative secant integral, but there's a minus sign distributed through this. So I end up with plus the integral of secant x dx. So the idea of this standard looping trick with integration by parts is that if I just give my integral a name real quick, I'm going to call it I, that's the integral of secant cubed x. I just noticed another copy of I on the right hand side. And I can move that copy of I over to the left-hand side, and I get 2i, so 2 times the original integral, is equal to secant x tangent x plus the integral of secant x, which I just have memorized, and that's natural log absolute value secant x plus tangent x. So it's kind of an indirect way of solving for I. I divide by 2, and I have an answer for my integral. And we don't want to forget the plus c right at the end. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.